Hey everybody, so in this stream here I want to talk about converting between expressions that have rational exponents and radical expressions and going back and forth. If you're in my class, this is Learning Targets 4 and 5, part of Unit 1. Alrighty? I'll give just a moment for a couple more people to get on. All right, let's go ahead and talk about this here. So real quick, first, we do need to talk about what the parts of an exponential expression happen to be. This here, b, as I labeled it, that is called the base. That is, I could call it the thing raised to the exponent. And what's an exponent? Well, that's this guy right here. It's the little superscript that's next to it. This is your exponent. Exponent. I think I put an extra E in there. All right, there we go. Okay, so that is the start of it. Now, the exponent that we're actually talking about here, rational exponents. Rational means it can incorporate fractions. So here's our new bit here, where the base is x. Okay, that's the thing being raised to the exponent. But the exponent is a fraction, n over d. N stands for numerator, and what we're going to call it here is the power. Okay, something like, for instance, if we said 2 to the third, 3 is the power, that's 2 times 2 times 2, that gives you 8. Okay. D, the denominator, the bottom, is the root. Now this right here is quite possibly the most important aspect of this whole thing. Okay, so basically if I were to put down, and I'll just do this in reverse, 8 to the 1/3 power, okay, the entire thing is the exponent. The 1 is the power, so 8 to the 1st power, nothing's going on there. And then here you're basically taking the third root or cubed root of 8, which is 2. Alrighty, so just put it back together again here. Numerator is power, denominator is root. This super crazy important. Denominator is root. Okay, so now this is a radical. All right, there's two parts here. While you probably have heard all the terms that I've talked about so far many times, these might be new to you. The piece that is underneath the radical, the thing that you're taking the root of, okay, that is called the radicand. Radicand. Okay? And this piece right here, and I use the letter D here for a couple of reasons, but this is the index, is what that's called. Okay? You're probably most familiar with the square root. Okay? You'll notice there's no number here. If there isn't one listed, that basically means there's a 2 that you don't have to worry about there. Okay, so that's why it's called square root, because there really would be a 2 there. It's just we don't really have to include it. Okay, now index, and I use the letter D. If we come back over here, here's the letter D. That is the denominator or the root. Okay, so the index is basically what your root is, and it's also the denominator of your rational exponent. Okay, now the radicand, that's the thing you're taking the root of. Okay, that might sound kind of similar to thing being raised to the exponent. All right, so the radicand is essentially the same thing as the base of your rational expression. Expression with a rational exponent. And guys, that's really all there is to it. Everything else here is going to be a bunch of examples, okay? So for instance, x is the base, which is going to be the same thing as the radicand, okay? So we can put the x inside the radical. The denominator of our exponent is the root. So we're just going to put a 3 in that little crevice there because that's the index. And then finally the power is 2, so I can raise it to the second power. Now there's a lot of different options here. If it's multiple choice type of question, you'll have probably one of these choices. If it's one where you're writing it or typing it in, it should all be accepted, but this is one way to write it. You could have incorporated parentheses here, so that you've got the cube root of x in parentheses being squared. Or, since order really doesn't actually matter here, you can put the exponent inside the radical. Okay? Now, that could be problematic if we were dealing with a situation like number 10, where it says there, note the numerator of an exponent. It could be larger than the denominator. You may have to further reduce the radical, okay? And that is something you're going to have to check with what the, assignment that you're working on is asking you to do. So for instance, here, it's a to the 5/4 power, okay? A is the base. It is also the radicand. Okay, the denominator of the fraction is 4, so that's our root or index. And then finally, you'll raise the whole thing to the 5th power. Now, I used parentheses there. Okay, again, any of these 3 ways of writing it would be okay. However, this one here could get you in a little bit of trouble here, because if we do the 4th root of a to the 5th, you might notice that, hey, there's a 5 underneath the radical there, and we're taking the 4th root of it. So really what we should be doing there is pulling 4 of those a's out, since you're looking for a group of 4. I'm not going to be concerned with that in my classes right now for Algebra 2. If you do need more assistance with that sort of thing, go ahead and hit me up. I can help you out with that. But let's keep going with this here. Now this time, notice these are almost the same. Okay, here, because 2x is in parentheses, it's grouped together, that whole thing is the base. So it's going to form the radicand. 7 is the index, and then 3 is the exponent. Okay? The difference with 9 is that only the x is actually being raised to this exponent. The 2 is not part of that. So we're going to put the x inside the radical. 7 is still the index, and we're still raising it to the 3rd power. However, the 2 has nothing to do with any of that stuff we just wrote, so we're just going to put a 2 in front. You can leave it like that if you, I don't know, just really for more clarity, or you just really love parentheses, you can put it that way too. Alrighty. I'd already mentioned number 10. Note, if the numerator of an exponent is larger than the denominator of the exponent, you may have to further reduce the radical. Kind of like what could have happened here. You would have pulled out one of your a's and then left with the 4th root of just a. Okay, but we are not going to really concern ourselves with that for my classes right now. Okay. Anyway, let's go the other way. Rewriting each radical as an expression with rational exponents. A lot of people call this easier. It very well could be. X is the base. Okay, this is your power, and well, that is your root, your index. So when we make our fraction, 3 goes on the bottom, it's the root, 5 goes on the top, it's the power, and we're done. Yeah, went by really quick, didn't it? This time, we've got A as our base. 5 is the index, that's our root, it's our denominator for our fraction. And then the 4, since that is an exponent, just an integer exponent, well, it's going to be to the 4/5 power. Okay. All right, just 2 more of these, and then we'll be all set, actually. It's kind of a short live stream here. This time, we can start it off and say that 2x, the whole thing, is the base. So I'm going to put that in parentheses, so there's no issue with it getting split up. And 7 is definitely a power, okay? The root, or denominator of our fraction, is the number that goes right there, and there's nothing there. If you remember what I said just a few minutes ago, if there's nothing in that spot, well, that means it's a number 2. It's a square root, okay? So there you go. It's 2x, all in parentheses, raised to the 7/2 power, 7/2. Okay. How are we doing? Great. And just one more here. This one, well, it looks a little different here. V is our base, and 4 is the index, so that's definitely going to be the denominator of the exponent. But goodness, I don't see anything else to make the power. Keep in mind, one exponent that's always there, if you see nothing else going on, would be raising it to the 1st power. So in other words, this is V to the 1/4 power, which is the other way of writing the 4th root of V. And guys, that's basically it for how you go about converting back and forth between expressions that have rational exponents and radical expressions.